And it's the same on the other one, except the order is switched. Now let's look at the next one. This was an example of Simpsons Paradox, and I thought it would be nice to use Bart and Lisa Simpson as examples, whereas Bart takes out mostly easy courses, and Lisa takes more difficult courses, but look at their overall GPAs. Even though Lisa does better in the easy courses. She didn't take very many of them, but when she does better, and Bart does better, and Lisa also does better in the difficult courses. 3.4. Bart tried one difficult course for 3 hours, and boy, did not do well. But look what happens with the overall. This is Simpsons Paradox. How is this possible? Look at this. Bart, with the overall GPA, outscored Lisa. This is why they weight your GPAs in high schools, because some courses are harder than others, so to make things more equal, because the colleges often only go by your overall GPA. So this is an example of Simpsons Paradox, and so this is how it looks here. And if they both decided to take one more course based on these results, of course, Lisa, you would think, would do better, because nobody takes an overall course. You take either an easy course or a hard course, and in either case, Lisa scored higher. So the other one, let me show you the other key on this page, just so you won't get confused. This is what it looked like. Things were switched, but these two answers were Bart and these two are Lisa. And here's how it looked. Any questions on that? All right, so let's go to the next page then. And on this one, people did pretty well on this one. So let me just show you what 2 points. For this one, here's how the answers looked. And these are online, just where your practice exams are. So which one is this? This is the stat, without the S, okay, stat. And let's see what it looks like on the other one. Here are the answers, just so you can see. Okay, so this is the stats. Any questions on that? All right, we're going back to stat. I'll do stat first, then stats. All right, so this one was a fairly difficult question. What do you do with people who drop out of a study? It's a good randomized study with a treatment and a control randomized assignment. But then what happens? This always happens. Some people drop out of the study. They're called slackers or non-adherers, and the adherers stick with the protocol. And in this case, the adherers did better. And that's typically so because they stuck with the program, and they're probably more responsible in other areas. Adherers chose themselves, so they may differ in other areas, like diet, sleep, exercise, etc. So we can't compare. So many people did the 10 versus 2. Well, why don't we do adherers and non-adherers here for you to look at? I say not applicable. Why? Because with meditation, you can't have placebo meditation. This was a study on whether meditation lowers your blood pressure. You can't see who would have adhered if you had a placebo meditation. People would know if they're meditating or not. So this is a study where you can't have a placebo, so you can't see that. So you have to compare the original randomized assignment. And let's look at the other one. The other one was the same way, 3 versus 3. Any questions on that? All right. A lot of people got that wrong. Feel proud of yourself if you got that right. It was a hard question. Next one, the same histogram for both. And what you were given were this was the missing block. So you had to fill in all these areas and then realize that, okay, these all add up to 85, so this must be 15. So that's what's here. That was the same on both versions. But, and then, let's see what else we did here. Okay, this one said, what percentage? Exactly 12. Well, exactly 12 would be 4%, because this 4% is, you assume an even distribution here, and it's 4% for each drink inside here. And the average is greater than the median because it has a long left-hand tail. These extreme values out here pull the average up. Let's look at the other one on the same page. And let's see what they say here. Okay, it's very similar. The The only difference is what? I asked for 2 alcoholic beverages, so the answer would be 5 for this one. And then the median is less than the average. If the average is greater than the median's less than the average. Okay? Any questions so far at all? All right. So let's go back to the stats version. Okay, the stats version is right here. Oh, this was a hard problem, this last one. And if you got this one right, feel proud of yourself. Not many people got it completely right. It was a hard question. So let's look at this. And it was what you hadn't seen anything quite like this. Okay, so it says the histogram, look at the histograms below, they each have a data set of 10 whole numbers. 10 whole numbers. Well, that must mean that all 10 numbers are 3 here. So they have to have an average of 3, and they have to have a standard deviation of 0. How about the next one? Well, you can see half the numbers are 1s and half the numbers are 5s, so that's the average. And here's how the numbers are distributed, and still the average is 3. So most people got that they all have an average of 3. Okay? And then the next one is, which has a standard deviation equal to 0? This one, because every single number is right at the average, so they don't deviate. I scrambled the histograms, but it's this picture on the other version. Okay? And the last one, which has the largest SD? This was the hardest one. Well, that one couldn't, so it's between these two. So you look at these two, and you see, all right, see how these are more spread out? Every single one of the 1s has a deviation of 2 below the average, and every single one of the 5s has a deviation of 2 above the average. So your deviation has to be 2. Here, look at this. You have 4 numbers here, lots of them these all have deviations of 0. You have one that has a deviation of -2 and one that has a deviation of +2. So this has to be smaller. And this has to be the biggest one. So what did we get on the other one? Here's how the answers were. We just scrambled them. So this is on the stats version. All right, let's go to the next one. And here, this was the one where, unfortunately, I made a typo on the key. It's correct here. So nobody should have this crossed out on the stat version. Because what are we doing? This is the width of the interval. You see how 15 minus 5 is 10. This one's correct. Hello? This one I made a mistake on. Look, if you had the stats version, and I couldn't announce, if you have the stats version, the whole point is you're not supposed to know who has which version. So I said if you had 5 to 10 here, and you want to take the width of that interval, 10 minus 5, what's wrong with that? It should be 5. All right, so this is how it looks. If you had the mistake, it looks like this. All right? 30 over 5 is 6, and that's what it looks like, and that's what your histogram looks like. That's the stats version. Any questions on that? If you didn't have the mistake, well, this is what it should look like. You're doing 30 divided by 10. You should also look and see, look, that is a 30%. That's a big area there. You should make sure that they match up. The areas look reasonable. And then it says, what's the median? Well, you could have looked just right up here. It divides at 50, 50, so the median has to be 15 on this one, whereas on the other one, if you divide the graph up 50 by area, the median has to be 10. So the median here is 10. All right, now, the number of people who answered 0 to 5 is 20. The number who answered 5 to 15 is 30, so that's less than. And on your other version, it was more than, because it was 10 to 20, which is 35%, versus what? 5 to 10, which is 20%. Okay, now, let's look here. And most people did pretty well on this one. This is the stat version. They did pretty well across the board, except for where? Here. Change every number to a z-score by subtracting 6 and dividing by 2. That's good, that's good. But what happens when you subtract? Look at this. The standard deviation is 2. Should we subtract 6? Will that change the standard deviation? If you take 6 away from every number on the list, you shift the histogram down. Does that change your spread? So that one you can ignore, the 6. Subtracting 6. But does dividing by 2 affect it? Yes. So if you take 2 divided by 2 is 1. And notice, when you change to a z-score, you always have a 0 average and a 1 standard deviation. That's what happens when you change to a z-score, and certainly it did there. All right? Now, let's look at the other version. And this is what the other version looks like. Any questions on that? 1 point each? All right. Now let's move on to the next one. And this was just computing a standard deviation. And you can see this was really hard to grade if people made careless errors on here. Please check that your score that you actually got is the same as your score online. We did some regrading and gave some people some more partial credit on this problem. We went through them all again. And so you might have earned some more credit on this. Make sure that you got that recorded. Look at your score in the front. Make sure that's the score on Compass. All right? So that's what this one looks like. Most people got it right, but some people got it wrong deserve some partial credit. We had to go back and regrade everybody's. Okay. Any questions on that? This is the square root. This is the square root of 10, and this one was the square root of 7. That comes out to 42 over 6. All right, let's move on. And our last page looks like this. Now, if you have continued error anywhere on your exam, what it means is that we're giving you partial credit. It means you made a mistake somewhere at the beginning, like for example here, if you didn't get 1.75 as your z-score, well then you're going to get this wrong. So we mark this wrong. If you got it wrong, let's say you put 1.85 or something, but then we assume whatever your answer is here, we grade from there on in. Sometimes it gets very complicated, but it means when you have continued error, it means we're trying to look through your problem and see if you know the logic, even if you might have made some careless error at the beginning or made some mistake at the beginning. That way, if you make an error at the beginning of your problem, you don't suffer any more than somebody who makes a mistake at the end of the problem, the same type of mistake. So it takes a long time to grade them, and that's why some of your papers might be completely marked up, but you only have a couple of points taken off, because we're trying to show you the right answer and everything through. Okay, so this one looks like this, and a lot of people didn't shade correctly, so they missed a point because they were shading the wrong area, and this is what it looks like. All right, for this one, let's just look quickly at the other one. The top half of the other one looks like so. This is the top half of the other one. All right. This one has continued error on it too. Okay, so now we move down here, and this was a hard problem, and I was very proud of everybody who got it. What did you have to do? You already used the 1.75, but now I just want the area between these two. That's kind of hard to do. People did it different ways. Some people took half of the 68 and then half of the 92. Some people took the 68 in the middle and then looked at these two pieces by taking 92 minus the middle portion. That would give you the area of those two intervals divided by 2. You get the same answer either way. So let's look at the other one. Same thing. Some people took half of the 68. Half of this, excuse me, how did they do this? This is 38. So some people took 1/2 of the 38, that part, and then half of the 68 goes from here to here. 68 goes all the way to there. Okay? And that's this one. Then other people did 38 in the middle, and then they just did this piece by taking 68 minus 38 over 2. All right? I was really pleased. A lot of people got that right. I was surprised. Okay, so now the next one is just negative and 0 and 135, and same here. Negative 0 and 135. These are online if you want to look at them. All right, now finally our last one. How old were you when you had your first kiss? This is the first time I've ever asked this question. How old were you the first time you kissed someone in a romantic way? And 12% said they're still waiting. I don't know if that means they've never kissed anybody or it just wasn't so romantic. I don't know. Can't tell, but 12% said Still waiting. So if we took those off, deleted those 12%, the rest of the people followed a normal curve with an average of 15 and a standard deviation of 2.5. And so here's what we had, these Ninja Turtles here, and Donatello, what was he? 20 years old. So that was thanks to David back there. He knew more about the Ninjas Turtles than me. So there we had 2 and 97.5 percentile, continued error. Lots of people got a little confused. The percentile is everything below. So some people got your papers very marked up on, with a lot of partial credit and continued errors here. All right, and then what's the next one? Oh, let's look at this one. Who do we have here? Donatello here was 17.5 only, so it's, why is this 2 as well? What did I do here? This shouldn't be 2, should it? Look at that, 17.5. What should this be? We have to change this. This is 17.5, correct? Minus 15, those of you who have this version, stats. We have 2.5 over 2.5, which is what? Isn't that what you had? Right? This key is according to the wrong version, this stats key. So then what should this be? 1. And so then what did you have here? I'm very sorry about this. It was graded right. We just did the key wrong. Thank you. So it's 68 in here. It was graded correct. It's just we wrote these pretty keys afterwards and we messed up maybe. So that's 68%. And then it's going to be everything from here on in. So here, let me show you. Oops. 68 plus what's this, guys? 16, thank you. So it's 68 and 16. This is 16, we'll cross that out. And this one's 16. So the percentile is everything below, so it's 68 plus 16 is 84. Just add those two together. All right, so that's the answer to this one. Everybody understand? Let's go back to here. And now what are we doing? 0.6. Okay, so 0.6, you got 48 in the middle, correct? And then you had to get this tail. So you had to add those two together. And then how did you change from 0.6? You said, oh, let's start at the average, 15, and add 0.6, but not 0.6 years, 0.6 standard deviations. And on this one, what did we do? It was 1.6. Uh-oh. Shouldn't have the same answer. Whoops. So this is what? 1.6. In the middle is what? Is this correct? 89, correct? And so then you add 5.5 to it. That's correct. Then you go here and you say 15 plus 1.6 times 2.5. That can't be the same thing. What is this? What is it? 19? Yeah, 19? Yeah. Sorry, guys. I got to change this online. All right. Everybody understand? All right. Now let's go to the next one. Okay. So now here, 16th percentile means you're below average right here. That means this person, Raphael, was young when he got his first kiss, very young. All right, so does that surprise you with Raphael? I don't know. So you have 68 in the middle, 16 on both sides. That's -1. We looked it up, -1, and that means 15 minus 2.5. Oh, only 12.5. All right, let's look at Raphael here. Same guy. Oh, 4th percentile here, he's really young. So 4th percentile is really young. So you look up, put 2 4s, 4 and 4. 2 tails, same. Inside middle area is 92. And then you look up 92 and you get -1.75. -1.75, so you say 15 minus 1.75 times your average, 10.6, very young. Okay, now we're going and we're just doing I hope you saw these two were related, just the opposites. This is 16 below, and 84 is 16 from the top. They add up to 100. So these should be opposites, and instead of subtracting 2.5, you should be adding it. So Leonardo is just as, sort of like Raphael's opposite, just as slow to do this as Raphael was fast to do this. And we'll go back and do the same thing here. Yeah. So we do the same thing, and what's the opposite? 96. See how 96 and, what are we talking about? 96 and 4 adds up to 100. So 96 and 4 is 100. And fourth, now Leonardo's older, way up here. He's positive 1.75. So we add the same amount we subtracted. Any questions on that? All right, if you have a question on your own, see me afterwards. And I'll get these keys corrected online. I'll make a note of it. Sorry about that. They're pretty, though. Not my handwriting. You can tell. All right, so let's get quickly to the notebook. And we left off where we're talking about the correlation coefficient. And what we're going to do is, we said the correlation coefficient is a measure of the strength of a linear association between x and y. And if if you had a perfect correlation, all the z-scores would be equal. Zx would be equal to zy, all the points would be on a line. That's as far as 1. Well, how do you compute this correlation coefficient? The very first thing you have to do, since it's based on z-scores, is change the x to z-scores and the y to z-scores. All right, but before that, let's just check out these points and see what they look like. These are 4 students, quiz 1 and quiz 2 scores for the 4 students. So let's just quickly plot the points. First student got what? A 10-10. Very good on both. Second student got a 9 on the first exam. Quiz, let's put the quiz 1 here and the quiz 2 here. All right, see a 9 and a 7. So that's right here. Let's do the next person is a 5 and a 9. Right there, there's only 4 of them. And the last one's a 4 and a 6. All right, so just check those 4 points out. And do you think there's only 4 points, but do you think that this is a positive correlation? Do you think it slopes up, slopes down? Oh, it's footsteps across the stage, you see? I was wondering what that was. I was hearing somebody walk across the stage. You see the feet under the curtain? Spooky. Okay. Now, so does it slope up, down, or neither? Can you just eyeball it? So what do you think? Raise your hand if you think it slopes up. I do too. Doesn't it? You see how it slopes up? If it didn't slope either way, it would look like a rectangle. Yeah? Do you have a question, anybody? I can't hear what you're saying. This is the problem with getting old. I'm semi-deaf. It's awful. I can't hear. You could say anything about me. I wouldn't even know. I'd say, oh, ha, ha, ha. You could, what? I'm not the only one. There's a young person here who can't hear me either. Yay. Tell me. Somebody yell out. Tell me what you're saying. Oh, it looks like it's neither. No. It looks like it's neither. Yeah, I can see easily why you'd say that. You know what neither would look like, though? Neither, neither, let me show you on this other notebook so I won't mess you up. Neither, page 84, let me show you what neither would look like. Neither would look like 84. Okay, these 2 points, check this out. What if it was like this? Look at the heavy points. Do you see how that would, forget the light points and forget that one. That would be neither. Can you tell the difference? Those 4 points form in a rectangle, then you wouldn't know whether it goes up or down. Just erase those little points. If you had 4 points like that, wouldn't that be neither? Do you get it? This one's sloping up. See how it points like an arrow up? Do you see that? All right. And so let's get back to it. Okay, so now we've got to change to z-scores. So you don't want to compute the averages and the standard deviations, and I want you to know how to do that, but I'll save you some time, and I'll tell you what they are. So the average of the x's is 7, and the average of the y's is 8. Standard deviation of the x's is about 2.5, and the standard deviation of the y's is about 1.6, okay? So that's what we have. Now, we want to change to z-scores. So what are we going to do with this 10? 10 minus its average, 7 over 2.5, right? Value minus average over the standard deviation. Let's do that with all of these. So we have 9 minus 7 over 2.5, 5 minus 7 over 2.5, and the last one's 4 minus 7 over 2.5. So what are these? 10 minus 7, 3 over 2.5 is 1.2. And negative 3, see how this is negative 3 over, that's going to be negative 1.2. 2 over 2.5 is 0.8, and this is negative 2 over 2.5, so that's going to be what? Negative 0.8. And notice something. Notice how that these sum to what? 0. And you know what? They're always going to sum to 0. So the z-scores will always sum to 0. Why? Does anybody know why? Look at the numerators. Those numerators are the deviations from the average. That was just on your exam. See these numerators? That's just the deviations from the average. Don't they always sum to 0? Don't they? Yeah. So if the numerators are all 0, then this is going to sum to 0. So always check. Yep, sums to 0. So you know you didn't make a careless mistake. Let's do the next column now. All right, now these two, first of all, this person got the same score on quiz 1 and quiz 2. Does that mean I can just write 1.2 in here as a z-score? Do you think I'll have the same z-score? He has the same score. No, because a 10, look, the averages and the standard deviations are different. So the 10 on one quiz doesn't necessarily mean the same relative to everybody else as a 10 on the other. So let's check it out. This is going to be 10 minus 8 over 1.6, excuse me. 7 minus 8 over 1.6. 9 minus 8 over 1.6, and 6 minus 8 over 1.6. Do you see that? So let's look at that. That's 2 over 1.6, which is 1.25. So it turned out this was a little better 10. This person did better relative to the rest of the class. And this person must be what? If this is 1.25, what must this one be? Negative 1.25. All right. Now this one is 1 over 1.6, which is 0.625. So negative 1 over 1.6 must be negative 0.625. And you can see these all sum to 0 as well, and they have to. Now, if you're doing this and you don't necessarily have to get a symmetrical set of numbers like this. You don't always have to get a number and its opposite. Sometimes you won't. But you will always, they will always sum to 0. So it's a good way to check your work. If they don't sum to 0, that means you made some miscalculation and you have to go back and do it again. So that's a good way to check your work. All right, now what are we going to do? Let's zoom out a teeny bit. How do we get the correlation coefficient? Well, what we do is we multiply the z-scores. So we're going to multiply that, 1.2 times 1.25. And the same for all of them. All right? Now let's look at this one first. 1.2, that's the z and the x, times 1.25. We multiply those together and we get a positive 1.5. All right? And look down here. Negative 1.2 times negative 1.25 is also a positive 1.5. So let me show you what's happening. Let's look at those 2 points. That's the person who got the 10-10 and the person who got the 4-6. This person did above average in both. That's why he has positive. And this person did below average in both. He did below average in both. So let's look at what those points are. And I'm going to make them really big here. The 2 points we're looking at, it's these two. Those 2 points. Do you see how if I divide this graph up, the average for the x's is 7. That's the average for the x equals 7. And the average for the y's is 8. So do you see how this person and this person, when you have when you are both, this one's above average in both. His z-scores were 1.2 and 1.25 in z-scores. And this person was below average in both, negative 1.2 and negative 1.25. And when we multiply them together, see if the majority of the people are in this quadrant and this quadrant, do you see how you'd have an uphill slope? Because below average values would be on quiz 1 would be associated with below average values on quiz 2, and above average would be associated with above average. That's what it means to have a positive correlation. And so when you multiply negative times a negative, so this quadrant is going to give you a positive, and that quadrant would give you positives, positive products, when you multiply them together, as opposed to these two. Okay, check this out. Let's look at these. We'll look at the first person. This is 0.8. This is the point 0.8. He's above average. This is 9.7, so he's above average on the first, but then he sunk below average in z-scores, below average. So when we multiply these two, we're going to get a negative. And same here. This person is negative 0.8. He's only got a 5. He's below average. Negative 0.8 is his z-score, but he did do above average on the second one. He got a positive 0.625. So let's check it out when we multiply those two. Let's do it. So this is positive 0.8 times negative 0.625, correct? And then we're going to get a negative here. We'll get a negative 0.5. And we'll do the same here. Here we have negative 0.8 times positive 0.625, and we get a negative 0.5 again. So do you see how when you multiply these two, because they're doing the opposite. When below average values in one variable is associated with above average in the other, and same in these two quadrants, when these two quadrants dominate, you're going to get a negative slope. So the products here would be negative and negative. Now why? We have 1, 2, 3, 4. Why did I see, and most people saw, positive? Because imagine these are stronger. Imagine if they were even stronger, if they were way out here and way out here. Well, then it would certainly be positive. Whereas if these are weaker, they're closer to the average here. If they got really small, you'd really see. Even if, let's say they were here, they'd still be negative, and there, you'd have a very strong positive correlation. Whereas if these were dominating, you'd have a negative correlation. And you can see that by the value of the products, the absolute value of the products. Here we have these two, which add up to 3. The positives outweigh the negatives that add up only to negative 1. So what is R? R is equal to the average of the products, the average of Zx times Zy. So in this case, it's going to be the positives add up to 3, 1.5 plus 1.5. And the negatives add up to what? What's 0.5 and 0.5? Negative 1. And we're going to divide them by what? 4. So we get negative 2 over 4, which is negative a half. That's what negative 0.5. Positive 0.5. Why I did that to wake you up. 3 plus negative 1 is not 3 minus 1. 2. Thank you. That's good. That's good. 3 minus 1. Thank you. Thank you. We knew it was positive, so R equals 0.5. Didn't I tell you it was a positive correlation? All right, do you get it? Do you get sort of the reasoning why these products make sense? Why it makes sense to compute a correlation coefficient this way? I didn't prove this is true or anything like that, but I gave you a sense of why taking the average of the products of the z-scores would make sense. So what happens if you do this whole thing? If you do this whole thing and you end up getting, let's say I got 1.5 here. Would that be possible? What if I got 1.5? What would you think? What? It's still positive, but you'd be wrong. Why? It's still a positive number, but why would you be wrong? Yeah? R can't go over 1. And if it is 1, If it is 1, what does the graph look like? What would those 4 points look like if it was r equals 1? Those 4 points would all be on a what? Line. Okay, does everybody know that? All right, so let's just do another one quickly. Oh. 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 Oh, you're gonna make me tired. Come on. Give me some energy. I know, isn't it a lazy day? What is it with us, with me? All right, let's speed this up then. Does that sound good? All right, so look at these points. First off, let's graph them. Always graph them first. So this is 1 through 7. Let's graph them. First we have 1, 4. Where's that? 1, 4. What's our next one? 2, 1, 3, 6, 4, what? 3, 5, 2, 6, 7, and our last one is 7, 5. Now, what do you think? Do you think that's positive or negative? Correlation. Positive. Don't you think it sort of slopes up? Not down. All right. So how would we figure out the correlation coefficient? Well, the first thing we do is get the average. You can see the average here is what? It's going to be right in the middle. The average of the x's will be 4. Now, these are all the same numbers, but in a different order, scrambled up. So what must the average of the y's be? If they're all the same numbers, what does the average of the y have to be? 4, thank you. And this standard deviation, do you want me to do it or not? Oh, okay, I will do it. Standard deviation of the x's. How are we going to do that? Well, let's get our deviations. Where should I put them? We can put them right here. What are our deviations? Our deviations are going to be, we're going to say 1 minus 4. What's that? Negative 3. 2 minus 4, negative 2. 3 minus 4, negative 1. 4 minus 4, 0. Now, 5 minus 4 is what? 1. 6 minus 4 is 2. And 7 minus 4 is 3. Those are our deviations. Now, what do I have to do with all of them? I can't just add them the way they are, because I'd get 0. So I have to what? Square each and every one of them. And then what do I do with them? Take their average, so I'm going to add them all up and divide by however many there are, which is 1, 2, 3, 4, 5, 6, 7. And finally, what am I going to do? What's my very last step? Square root. So let's see what that is. So, this is 9 and that's 9, correct? I have to do this. They're going to all be positive there. Okay, so that's 9 and this one. So I have 20 and 20 and 4 and 4, 28. All right, 28 over 7 is, so we have the square root of 28 over 7, which is the square root of 4, which is 2. So that's what we're going to put here, 28 over 7. All right, so that's our standard deviation for the x's. What do you think our standard deviation for the y's is then? They're the same numbers. Same thing. We're good. All right, so now we're ready to roll here. So we just say 1 minus 4, 1 minus 4 over 2, correct? Isn't that all we're doing? 1 minus 4 divided by 2. 2 minus 4 divided by 2. 3 minus 4 divided by 2. 4 minus 4, that's where the 0 is. 5 minus 4 divided by 2. 6 minus 4 divided by 2. And 7 minus 4 divided by 2. That's going to be our z-scores. So what do we get? We get negative 3 divided by 2. Negative 2 divided by 2. Negative 1 divided by 2. 0 divided by 2. 1 divided by 2, 2 divided by 2, and 3 divided by 2. Add them all up, and we do get 0. All right? So now we will do the same thing with the zy's. Start with 4. 4, same average and standard deviation. 4 minus 4 divided by 2. There we have our 0. 1 minus 4 divided by 2. 6 minus 4 divided by 2. 3 minus 4 divided by 2. I'm just going here. 2 minus 4 divided by 2. 7 minus 4 divided by 2. And 5 minus 4 divided by 2. All right, you have to catch me if I make a careless mistake. Please, promise to. Let's move in here so you can see it better. Let's zoom in. I hope I didn't. You go on an automatic pilot and you could easily just, all right, so let's see what we get. And what do we get here? Negative 3 halves. Here we get what? Negative 1, negative 1 half. Here we have 1, here we have 3 halves, and here we have what? 1 half. Now I would catch my careless mistake if these didn't add up to 0, but they do, so I think I'm good, right? Did I do that right? No, I did it wrong. This should be positive and this should be negative, correct? Now I did it right. So they still added up to 0, but just because I made 2 mistakes, they canceled each other out, sorry. Is it good? No? Okay. All right, so now what should we do? Now we are ready to multiply. So what do we want to do? We want to multiply this times that. So what do we do? What do we get there? What do we get? 0. What do we get here? 3 halves. Here we get, that's a positive. So it's what? 1. A positive times a negative is a negative 1 half. Here we get a 0. Here we get another negative 1 half. And here we get a 3 halves. And what do we finally get? A 3/4. Okay. And now, let's look at this. And see what R is. R is going to be what? It's going to be R is equal to the average of all those. The average of these, of the z-x's times the z-y's, of those products. So let's see what we've got. 3 halves minus 1 half. This together, up to here, this all together is what? 1. Is that right? And here's another 1, and this is 3/4. So I have 1 plus 1 plus 3/4. So I have 2.75 divided by 7. Is that correct? Yeah. 2.75 divided by 7, so that's approximately 0.4. That is my positive correlation coefficient. Any questions on that? It's very tedious, isn't it? But I want you to just understand the logic of it. And you're going to have one like that on your homework. How many people have already done it? Okay. It's due Wednesday. It doesn't take very long. I filled in a lot of it for you. Now, we could plot these as z-scores, and you can go ahead and do that, and you're going to get a plot that looks pretty much the same. You can do that on your own. And now let us look at this page. And what time is it? All right. So, remember we looked at how the average and the standard deviation changes when you do linear transformation, which means for example, if you add a constant or subtract a constant to every number on a list, or if you multiply or divide every number on the list by the same value, we looked at how it changed the average and the standard deviation, correct? That's what was on your last exam. Now we're going to look at how it changes the correlation coefficient. But before we do that, why don't we just think about it conceptually so you'll be able to remember it better. So let's just imagine a really simple case, okay? So I want to know how multiplying all the x or y values by the same number or adding the same number to all the affects the correlation coefficient. Okay, so I want to know how that would work. So let's just pretend that we have, the x equals y line here. So that would be, if you have let's say all the points lie on this line. So what is r in this case? If all the points lie on this line, what is r? R is 1. Now, what if I multiplied, or first let's just add. What if I added 5 to every single x value. So I had x plus 5 equals y. X plus 5, what would that do? It would just move this line over. This is 0, 1, 2, 3, 4, 5. It would just move it over 5. You know, be exactly the same line, but you would say, is that right? X plus 5? No, it would move it the other direction, right? X would be smaller. No, x would be larger, right? X plus 5 equals y. Y equals x plus 5. Okay, it would just shift it over by 5. And if I subtracted, it would shift it over that way. Correct? Correct? So, would that change the correlation coefficient? Would it? If I have a line over here or a line over here? No, it wouldn't. Now, how about if I multiplied all the x or y values by 2? Would you still be able to perfectly predict x from y if we multiplied all of them by 2? For example, if I said y equals 2x, and then it would look like, instead of having a slope of 1, it would look like a line like that. A line with a slope of 2. This would be y equals 2x. If I multiplied all the x values by 2, would that change the correlation coefficient? No, it would still be r equals 1. So multiplying, how about if I said r equals a third of it? Y equals 1/3 of an x. No, it would be like that. Even if I combine them, 2x plus 1. No, it would just be like that, 2x plus 1. So it would it change the correlation coefficient if I did any of those linear transformations? Would it or would it not? It would not. Now, one other thing that I want to ask you is, what if I decide to multiply by a negative number? So let's just do the same thing. Here's y equals x. But what if I multiplied all the x's by -1? Yes, it would. What would that look like? That would be y equals -x. And now what would the correlation coefficient be? It slopes down, so it would be what? -1. Now let's try another thing to see so that's the only way the correlation coefficient would change with a linear transformation they're still all lines. So it wouldn't, what if I switch the x and y axes? Like, what if I switch the x and y axes? Let's look back here. What if x and y were switched? Do you think that would change anything? No. Why? Because zx times zy times zx is zx times zy. What we need to do right now is a clicker question. We're going to do clicker questions on this. So get out your clicker questions. Get out your clickers. Good. All right. And let's pull this up. And whoa. All right. So let's look at this first one. I'll start the clicker. And so does R change? A, B, or C? We're on this one right here. Just answer. And it's the same as in your page, on your page. Thanks, Jackie. Hello? It's back on. All right, so I'm going to stop this. Everybody done here? And the answer, was no, and let's see if you all got B. Hooray, yay. Woohoo, okay. You guys are amazing. Okay, next one. Does R change? We're doing this one, I'm starting it. Here's the one we're doing. We're at this one, multiplied by 2. Does R change? I'm always going to do a clicker question on when I return the exams because I want to know who didn't pick up their exam. And I have to lug them around. I want to give credit for people who came and picked up their exam. Because I have to bring all those back. People who didn't pick them up. Are we done here? Everybody good? Raise your hand if you still haven't. Okay, we'll stop. Let's see how you did. So the answer here should be no as well. B. Ah, come on. No, it should be. Okay, there's all, pretty good. Very good. All right, next one. We're doing this one, number 3. Does R change if all the y values are multiplied by -2? A, B, or C? Okay, anybody need more time? Can I stop? Stop. It should be only the sign changes. Let's make sure you're good. Oh, yeah, it does. Oh, that's ambiguous, right? But what would be the best answer? C. But I'll give you credit because, yeah, it does change. I should have said, wait a minute. You guys who wrote yes, did you really think the number was going to change or just the sign? Okay, good. All right. All right. Now we're going to the next one. Wait a minute. I want to go to the next slide. Come on. Whew, nice. Thank you, David, for doing this. Okay, here we go. Does R change of all the x and y's? You switch the x and y's. That's all you're doing. Think about how you compute R. Does it matter if you multiply zx times zy or zy times zx? Now that's a hint. And think about this last one if you've already finished, because that's the next one we're going to do. Okay. Anybody still? Can I stop it? Okay. And the answer is no. Good. All right, last one. We're doing this one, the last one. Now, think about it. On the other page, it's on the questions asking you in your notebooks on that first, on that page. If you just switch that first row, what is it? The 1 and the 4 and change it to 4 and 1 or vice versa? What is it? Yeah. X is, what if you change 1, 4 to 4, 1? What do you think would happen? Do you think your correlation coefficient would change or not? You're just changing one of the points, the x and y's on one of the points. All right, let's see what you put. We're stopping it. Anybody still voting? More people voted on this than anything else. How come? Where are we getting these extra people? Okay, stop. We have ghosts in this room. All right, now, let's see. The answer is yes. Yes. It does change. All right, let's go back, see why, and then we're going to, okay, here. Why does it change? Look at this. If you switched, you guys are so squirrely. Come on. You're having fun? No? All right, so 1, 4. Hey, listen up. We're not leaving yet. We have 2 more important things to do. Really interesting things. 1, 4. Look, if you switch the 1 and the 4, wouldn't that change it? It would change everything. It would change the averages. The standard deviations would change. If you switch just these 2. Okay, let's quickly do the last 2. Let's quickly fill this in. Does R change? No. This was no. This was no. This was only the sign changes. And this is no, and this is yes. And where are all these rules? So I don't have to write them all out. All these rules are right here. So you remember these, okay? Now, we have 10 minutes left, but I think we're gonna go another few minutes because I really wanna do these last two questions and they're on your homework. And then I'm gonna put up a slide telling you how to exit this place. So nobody can leave now, I'm serious. Everybody has to wait. What, we have like what? It's only 5 after, correct? Oh, you guys are being bad today. Maybe I should not give you those eye clicker points. I'm teasing you, but I don't want, you're gonna get the eye clicker points, but you all have to be quiet right now. I know you feel like doing something, we have to learn this, all right? And it's actually pretty interesting, so watch. All right, so what happens with these outliers? What is an outlier? So here we are. An outlier is a weird point that's off the distribution. Like, do you see how all the points here pretty much follow a line? But this is an outlier. And over here, do you see how all the points look kind of random, but this is an outlier? They happen all the time on our data. Somebody who's really far out on the distribution, and we have to decide whether to include them or not. Maybe it's just a typo. Or maybe there really is somebody that far out on the distribution. Maybe there really is somebody who, like one of our questions, who slept with 50 people already. How do we know if they're lying or not? You know, there's ways we can check, we can look at all their other answers, but at some point we have to say, okay, we have to say, all right, why does when we're looking at correlations, these outliers that might just be typos or lies or mistakes, or they could be real data, they have a very strong effect on the correlation coefficient and can really change things. So we have to look at this, and for example here, we have a very strong positive correlation. But when we include this outlier, do you think it's going to lower R or raise R? If we include it, we have a very strong, so this outlier is going to what? Lower. Good. It will lower R and mask this. Maybe we have a very strong correlation. So first you have to, so it's important when you have outliers to both show the scatter plot and the outlier, how strong an effect it has. Now they don't only lower R, look at this case. You have no correlation basically. All of a sudden you put this person in who says, well, I don't know, he has 50 lovers and he like, what could be up here? Maybe, I don't know, a zillion, dollar, a huge amount of money or something? Well, maybe that would make sense because he's paying for it, but whatever. You know, this person way up here, okay? Here you have like no correlation. You include this and do you see what happens? So in this case, what could an outlier do to R? Raise R, could make a much stronger correlation than really exists. All right, that's really important, and you're gonna see that in your homework on brain weight and body weight in humans and dinosaurs and all sorts of animals. Okay, now, let's go to this last, and this very last page is about something called ecological correlations. What are they? They're not really about ecology. They're correlations based on averages. And correlations based on averages tend to inflate R. What do I even mean by that? I mean that each data point, instead of representing an individual, represents an average over a lot of people. So here's an example. The correlation for education and income for US men is about 0.44. That's if you look at all the millions of points, all the millions of men and their education and their income. But what if instead you just have 51 pairs of points? You condense all those millions of points into just 51 pairs. How do you do that? One for each state, including Washington, D.C. So for example, I took all the millions of men who live in New York or Illinois, let's say Illinois, and I took their average income and their average education. And you get a different correlation. It tends to be much higher. Why? What's going on there? And why it's so important is because in the newspapers and in many studies, people confuse these two. And they think, oh, there's such a strong correlation, 0.64. There is when you do the averages, but that doesn't mean that you can predict individuals with that type of accuracy. So let's look at why that would happen. So here's just a very simplified diagram of that same example. These 4 men, say there's only 4 men in state A. So we take their average and we condense them into 1 point. Okay? Average education and average income. So you eliminate all that with in-state scatter. And we do the same thing with all the Bs. And we eliminate all the scatter with in-state B, and all we're left with is this between-state scatter. And do you see how this correlation is so much stronger than this one? Because you've eliminated so much of the scatter. Does that make sense to people? Does that? So if you had, so I think at this point, I got to put this because I can hear noise outside. This will just take us a second, and I don't want anybody to move until I put the slide up, the PowerPoint slide, to show you how to exit, because I can hear the noise. People are getting excited about coming into this room and rededicating Lincoln Hall. So for each of the 5 statistics classes, the average in the midterm was, for 5 points, was calculated to be 0.97. Does that mean the scatter plot for all the hundreds of students would be that? No. It would probably be what? Be lower. There'd be more scatter. Okay? Now let me put that slide up for you all. We'll go back to the PC, and so you can see how to exit. So we're going to go to here.